Space Shuttle Disasters, Lessons from the Stars. Welcome to our deep dive into some of the most significant space shuttle disasters in history. Today, we'll explore the technical details, sequence of events, and the aftermath of these tragic incidents. From the Challenger disaster to the Apollo 1 fire, we'll uncover the factors that contributed to these events and the lessons learned that have shaped the future of space exploration. These are not just stories of failure, but powerful reminders of the complexities and inherent risks involved in pushing the boundaries of human ingenuity. Challenger, a cold and tragic dawn. On January 28, 1986, the world watched in horror as the Space Shuttle Challenger broke apart 73 seconds into its flight. The disaster, witnessed by millions, claimed the lives of all 7 astronauts on board and sent shockwaves through the nation. At the heart of the tragedy was a seemingly small component, an O-ring seal in the shuttle's right solid rocket booster. Now, O-rings, they might sound mundane, but these rubber seals played a critical role in containing the immense pressure generated during the booster's ignition. The investigation revealed that the unusually cold temperatures on that fateful morning caused the O-ring to lose its elasticity and fail to seal properly. This failure allowed hot gases to leak from the booster, ultimately leading to the catastrophic structural failure of the external tank. The Challenger disaster was a stark reminder that even the smallest components can have devastating consequences in the complex world of spaceflight. Following the tragedy, President Ronald Reagan appointed a special commission led by former Secretary of State William Rogers to investigate the disaster. The Rogers Commission, after months of rigorous investigation, identified the O-ring failure as the primary cause of the disaster. They also pointed to contributing factors, including flaws in communication and decision-making processes within NASA. The Commission's report led to significant changes within NASA, including a redesign of the solid rocket boosters and a renewed emphasis on safety culture. The Challenger disaster was a turning point for NASA and the space program. It underscored the importance of rigorous testing, meticulous engineering, and open communication in the face of risk. The lessons learned from Challenger continue to shape NASA's approach to safety and mission assurance to this day. Apollo 1. Fire in the command module. The Apollo 1 fire, occurring on January 27, 1967, was a tragedy that shook NASA to its core. During a pre-launch test at Cape Kennedy, a fire erupted inside the Apollo command module, claiming the lives of astronauts Gus Grissom, Ed White, and Roger Chaffee. The fire, which spread rapidly through the pure oxygen environment of the capsule, highlighted the fatal consequences of design flaws and inadequate safety procedures. The investigation into the Apollo 1 fire revealed a series of contributing factors. A short circuit in the spacecraft's electrical system provided the ignition source for the fire. The pure oxygen environment inside the cabin, intended to simplify breathing for the astronauts in space, had the unintended consequence of accelerating the fire's spread. The hatch design, with its inward opening mechanism and complex locking system, made it impossible for the astronauts to escape the rapidly engulfing flames. The Apollo 1 fire was a brutal lesson learned in the unforgiving realm of spaceflight. It forced NASA to confront critical shortcomings in its safety protocols and spacecraft design. In the aftermath of the tragedy, NASA undertook a comprehensive review of the Apollo program, leading to significant changes in spacecraft design and safety procedures. The Apollo command module underwent a complete redesign, with a focus on fire safety. The pure oxygen environment was replaced with a nitrogen-oxygen mix during pre-launch testing, significantly reducing the risk of fire. The hatch design was revamped to allow for a quick and easy outward opening escape in case of emergencies. The legacy of Apollo 1 extends beyond the technical improvements to spacecraft design. It instilled a profound sense of the importance of safety culture within NASA. The agency adopted a more cautious and methodical approach to mission planning and execution, prioritizing the safety of its astronauts above all else. Unwavering teamwork in the face of unforeseen challenges. Chapter 4, R16, a ground-based tragedy. The pursuit of space exploration has come at a high price, and those costs have not been limited to tragedies in space. The R16 disaster, a catastrophic explosion during a pre-launch test on October 24, 1960, stands as a stark reminder of the inherent dangers involved in rocketry, even on the ground. The R-16, a Soviet intercontinental ballistic missile designed to carry nuclear warheads, was being prepared for its maiden test flight at the Baikonur Cosmodrome in Kazakhstan. During fueling procedures, a malfunction in the rocket's second stage ignited the hypergolic fuel, a volatile mixture that ignites on contact, triggering a massive explosion. The resulting fireball engulfed the launch pad and surrounding area, killing an estimated 70 to 126 people, including military personnel, engineers, and technicians. Among the victims was Marshal Mitrofan Nedelin, the head of the Soviet Union's strategic rocket forces, who had been overseeing the test. The R-16 disaster, shrouded in secrecy by the Soviet government at the time, exposed critical flaws in safety protocols and a culture of haste that prioritized speed over caution in the space race against the United States. The investigation revealed a lack of adequate safety procedures during fueling, insufficient training for personnel handling hazardous materials, and a disregard for warning signs that had emerged prior to the explosion. The R-16 disaster had a profound impact on the Soviet space program, forcing a reassessment of safety procedures and a shift in culture toward a more cautious approach to rocket development and testing. The tragedy highlighted the devastating consequences of neglecting safety in the pursuit of technological advancement. The lessons learned from the R-16 disaster extended beyond the Soviet Union, serving as a stark reminder to spacefaring nations worldwide of the importance of stringent safety protocols, rigorous training, and a culture that values human life above all else. These incidents, while tragic, have led to significant improvements in space travel safety. By learning from the past, we continue to push the boundaries of exploration while prioritizing the safety of those who venture into the final frontier. Thank you for watching, and stay curious. The human journey into space is a testament to our unyielding curiosity and determination to explore the cosmos. But as we reach for the stars, we must never forget the sacrifices made along the way. The tragedies of Challenger, Apollo 1, Apollo 13, and the R-16 disaster serve as somber reminders of the risks inherent in space exploration. They remind us that the pursuit of knowledge and the advancement of technology must always be tempered by a profound respect for human life and an unwavering commitment to safety. As we move forward, let us honor the memory of those who perished in these tragedies by upholding the lessons learned and ensuring that safety remains paramount in all our endeavors.